My name is Moneish, and I'm going to talk about my project, which is coded aperture to obtain depth at all in focus image. A conventional camera captures blurred version of the scene information away from the plane of focus. Camera systems have been proposed that allow for recording all focus images or extracting depth. But to record both simultaneously, there is extensive hardware required. The main motivation is that with only minimal change from a conventional camera system, we seek to retrieve coarse depth information with together with a normal high resolution RGB image. This work is based on Levin's 2007 paper titled Image in Depth from a Conventional Camera with a Coded Aperture. The overview of our method is given an input image, we want to be able to get the depth estimate of the scene and also get all in focus image. Let us recap how defocus blur occurs. Any point on the focal plane is focused at a single point on the image plane. As the object moves away from the focal plane, the rays no longer map to a single point on the image plane, but rather to a region on the sensor known as the circle of confusion. The response of the optical system to point source is called point source function. The circle of confusion increases with the increase in distance of the object from the focal plane. So as the object moves more and more away from the focal plane, the circle of confusion becomes more and more bigger. Now, given a defocused image and calibrated point source functions at various depths, we can use deconvolution locally to get focused image. But the issue with conventional aperture is that the deconvolution results look very similar even at different scales, and it becomes difficult to distinguish the correct scale. Now, this is where coded apertures are helpful. The point source function for a coded aperture produce different results at every scale, and hence it is easy to discriminate between them. The pros of using a coded aperture is that it provides more depth discrimination than conventional filter, but the zero frequencies in the coded aperture PSF make the inversion process difficult, and it requires image prior for good reconstruction. So using a deconvolution method that does not use prior, such as Wiener deconvolution, leads to bad results. To reasonably use a deconvolution without much prior, we need to use calibrated kernels at the correct depths so that we can and we can do this by restricting the search space for finding the correct kernel scale to only these regions of interests. We use an off-the-shelf image segmentation model to obtain the regions of interest and restrict our search space to that only. Now let us have a look at some of the results. On the left is our input image. In the middle is the depth estimation obtained by searching for the correct kernel throughout the image. And on the right is the depth estimate obtained when we restrict our search space. We can see that the restricted search space with the restricted search space, we are able to get much better depth estimates. Here is the result of our all in focus image. We see that our result is sharper compared to the original image. However, since we don't use any prior in the deconvolution, we can still see some artifacts that come up as a result of that. And this is the main drawback of our system. These are the main reference for the slides. Thank you so much.